Welcome to Electric Perspectives, a podcast that explores how America's electric companies are working to deliver the reliable, affordable, secure, and clean energy that powers our economy and our everyday lives. The show is brought to you by EEI, the Edison Electric Institute, which represents all U.S. investor-owned electric companies. I'm your host, Brian Reel. As we start the new year, we're looking ahead to how AI will continue to impact the electric power industry and support the optimization of energy infrastructure, clean energy generation, carbon emission reduction efforts, and more. On this episode, we're thrilled to be joined by Arizona Public Service Company Chairman and CEO Jeff Guldner and Bright Night CEO Martin Herman to discuss how AI can create innovation in the clean energy transition, the ways in which electric companies are integrating AI into their operations, the efforts underway to lead a cultural shift on AI adoption in the workplace, and more. Welcome to the show, Jeff and Martin.
Great, thanks. Good to be here.
Thanks for having us.
Let's start by having each of you introduce yourselves. Martin, can you tell us a little bit about the company you lead, Bright Night, and your background in clean energy and the technology entrepreneurship side of it?
Sure, happy to. I started Bright Night in late 2018, and the thesis behind Bright Night was to develop a company and develop a portfolio to deliver not just energy from renewables, but also energy and capacity, because obviously as renewables get more and more used in power grids, you need to have capacity. This is obvious. It's very obvious today. Wasn't always that obvious. So we built a team around the portfolio. We're in today developing about 31 gigawatts, 70 projects in the US, mostly in areas where we believe, in addition to where capacity is needed, and renewable has an advantage to deliver that capacity. And then we are in fast-growing large markets in Asia that also need capacity and are buying renewables, most notably India, Philippines, and Australia. I started the company. I'm not just a CEO, but I am the largest shareholder. I invested a lot of my own money, but over time I took in two capital partners in 2021, GIP, which is now the infrastructure team at BlackRock. And then this summer we closed a capital raise with Goldman Sachs. So really happy to have two of the best-in-class capital partner on my side as we're continuously ramping up the portfolio. Last thing I want to say is I spent the first 17 years of my life in semiconductor, and now the last 15 years in the electricity industry. I've never really connected, that they were fairly decoupled from each other. And it's quite interesting to see that all of a sudden the tech sector sees in the electricity industry a sector that is where the growth and the expansion is depending. And having worked in both of these sectors, it's quite interesting I'm curious how, these two sectors will work together, because there's clearly a very different mindset, right? I mean, the most important one is the internet has no clock. The power grid has one, which sounds benign, but, from there on, everything develops, right? And the tech sector is proud to say, move fast and break things. And utility sector, it's about safety and reliability, right? So quite interesting to see how these two sectors converge, how that works, and we'll see much more of that over the next 5 years.
Thank you. And Jeff, for listeners who may not be familiar with the Arizona Public Service Company, can you give us a little background about your operations and how many customers you serve? And you seem to be one of those states where the amount of business and residential customers is just increasing annually.
Yeah, it's spot on. It's right along with what Martin was saying. We serve 11 counties in Arizona, including half of the Phoenix metro area, and we serve up in Flagstaff, down in Yuma, Tombstone, Bisbee, some of the iconic cities in the state. About 1.3 million customers. We're seeing a lot of these large industrials. Probably our biggest customer coming on right now is Taiwan Semiconductor, which is building its massive fab system in our service territory. We also operate the Palo Verde Nuclear Generating Station, which is now the second largest nuclear station in the country after Vogtle finished Vogtle 3 and 4. And, it really is just an exciting time, because we're seeing both the residential growth, which has been characteristic of Phoenix for a long time, but it's really now tied with that commercial and data centers, manufacturing. That's all coming in. And so it just makes the challenge, because Martin's exactly right. We don't like to break things. We're much more into the keep reliability and figure out how we get through our hot summers, here and then optimize the mix. We are also on a path to decarbonize by the 2050. Nuclear is obviously going to be a big piece of that puzzle, but a lot of work that's going on in that sector.
So partnerships definitely support the problem solving that's going on right now. Martin, can you talk a little bit about Bright Knight's Power Alpha platform and the type of partnerships you have with electric companies and really the aim of those companies? As I understand it, as Jeff just noted, a lot of our member companies have clean energy goals, emissions reduction goals, and it seems like this is a technology that's supporting those efforts.
Yeah. When I started Bright Knight, I did start a software team from the get-go. Bright Knight is my third company. As I said, I was in semiconductor before, and I had a software company. In that space, the software comes natural to me. And as we were looking at the thesis, how can you increase the capacity factor of renewables, you end up in hybridization, right? Hybridize something. The most simple would be solar and the battery. Once you start to design hybridized renewable power plants, you recognize, interestingly enough, there's no engineering software out there that you can go out and really helps you to optimize these power plants. On the other side, these power plants are $500 million to $1 billion in size. So it was very clear we want to have the most optimized solutions so that we can, on one side, deliver the highest value to the customer, but we also can help show the customer how these renewable power plants behave so that they can integrate it in the best way. And that's basically the thesis why I started a software team back then, and really happy after now 6 years developing it. It helps us on one side to get to what we would call a best-in-class design. It helps us optimize to what the customer actually needs. And we're using it to also integrate during the operations phase. So we have worked with a number of utilities and are working with a number of utilities right now to simulate how a power plant in their power grid could look like. And if we were to tweak it a little bit or change things, how the value changes. And it leads a little bit to a different mode of integration, partnership between the utility on one side and an IPP on the other side than in the past when, last decade, I developed solar plants and all you did was you had a project and then you filled out an RFP, least cost, best fit, fairly easy because 100 megawatt solar and 100 megawatt solar plant to compare. All it comes down to where in the grid is he, and that's what the utility understands quite well. But there's so much more in terms of value proposition and what you can do in optimizing once you add a dispatchability unit to a renewable power plant. That's where Power Alpha comes in.
Jeff, how is APS currently using AI in its operations? And as like other regions of the country, I imagine you're facing this rapid demand growth. Is this a tool you see helping meet that rapid demand?
Yeah, absolutely. And I just want to build off what Martin was saying, because I think it's so interesting to see the evolution of the complexity that is now in the dispatch models. And I heard a former utility CEO describe it this way. If you go back, 30 years, all you had to worry about if you were on the trading floor running the dispatch was, what do I do if I lose a unit? So you had basically a one-dimensional challenge, is how do I put the units on, and then how do I prepare for losing a unit? Then we got wind and solar and some of the non-dispatchable renewables. Now you're two-dimensional. What happens if something shows up that I wasn't necessarily expecting, and how do I manage that? When we added storage, and I'd say even some of the demand response, because that's one of the areas I think AI is going to be very helpful with, is on the customer side. When you add storage and customer-sided resources, you're now in a very complex three-dimensional model. And so some of the things that we're seeing, we've got a lot of batteries now going on our system here in Arizona, is do I discharge those twice? Do I charge them up when the solar's negative, dispatch them, recharge them, and then dispatch them again overnight? Or do I just do it once? That level of complexity is getting really difficult to figure out. To Martin's point, how do you optimize that with the rest of the resources that you have in? We're not quite there yet. I think that's an area that we see tremendous potential. I think where a lot of utilities are in AI deployment is, let's be fast followers. Let's go see what technology works. We're all risk averse. Sometimes you've got to take some risk, but we're probably being conservative in how we think about deploying it. Where we see immediate value cases for us right now, we are using it in our outage restoration prediction. One of the most helpful things that I think customers see is if there is an outage from a monsoon storm or something, that's typically where we see our outages, that we can give them an estimated time to restore that's actually closer and closer to the actual time to restore. So we're not telling them you're going to be out for 2 hours and then they're out for 6 hours. And we're actually using AI to improve and narrow that bandwidth. So we're getting pretty good outage restoration predictions. The other thing, I'll probably come back to this a few times, is making sure that your employees broadly understand the power and the potential of AI. So we do have Copilot enabled. We're starting to work that more, but we want to have employees who just kind of understand personally how this technology can help make their lives easier and help make the work that they're doing easier. If you build, it's like foundational. If you build that foundation, they're much more likely to say, hey, I've got an idea of a use case that I'd like to explore with additional AI, than if you've never seen, what the potential of a frontier large language model kind of AI can do. And then over on the nuclear plant, we know that there's going to be a lot of optimization that we can see on work management. We do 2 very complex outages. We have 3 units at Palo Verde, so there's 2 outages a year over there. And we've actually seen some really good efficiencies in the work management process. So using AI to build and prioritize the refueling outage work that we're seeing. So I'd say we're early on in the process, but we certainly see a lot of the potential that is there.
So it's not just trying to make sure you're efficiently meeting demand, it's actually opportunities to enhance customer experience and potentially find
Yeah.
some ways to save customers money.
Yep, exactly. And on the demand side, when we go there now, just on how I see it with optimizing demand response. We have a very large virtual power plant, mostly on smart thermostats. And so we can dispatch about 150 megawatts of flexible demand. The challenge is, and we're going to grow that. Our plan's actually to get up to about 1,000, about a gigawatt of flexible demand. If you have a series of hot days and you're essentially triggering the same customers every day for 4 days, people will start opting out. So you get less and less demand response on the second day, then the third day, then the fourth day. If at scale, you're able to use AI to optimize around feeders and say, okay, I need to get 25,000 customers today, and then a different 25,000 customers the next day, and then a different 25,000 customers the day after. That level of complexity is going to take machine learning and AI. It's not going to be something you can do on a spreadsheet. And so that, I think, ability to use customer-sided resources to help meet our demand is going to be one of those key use cases.
And Martin, you had mentioned energy storage a few times before, and I know the numbers that are being installed on an annual basis are substantial. You're talking in the gigawatts. Is the storage that's on the system now or even being added now utilizing the sort of software that your team is developing, or is there still a lot of untapped potential on the energy storage side of things?
The latter is the case. I think that there is untapped potential. Like Jeff said, we are all learning this new capability, right? If you think about it, as an industry, we are not using a storage unit as part of an intermittent resource since a long time, right? And the first installations were rather benign. So as an industry, we're trying to understand. I think we understand how we can construct it, how we can do the plumbing to connect them, etc. But what is the highest value use? And then Jeff made a great example in terms of, he has these batteries in his grid now. How do you utilize them based on what their capability is and really maximizing that? And I think that's a fairly uncharted territory for us as an industry, but it's certainly something that software can help. That is where software is good. And that's where you create lots of data, and then big data pattern recognition. That's obviously where machine learning and AI comes in, and training neural networks, etc. So I think there's a lot to be done. And again, that was for us a reason to start this software, which at this point, I should also say, it's fairly unique. I've hired engineers from most of my competitors, from the big guys down to the medium sized. And I've yet to see an engineer coming in and saying, oh yeah, my former employee had exactly the same software. So we started this around the thesis of hybridization. And as I said, 6 years in now, really exciting to see where this is going, how we can utilize this new capability in our industry.
Martin, I know you've written on this a little bit, but as EI's member companies, APS, of course, have really been leaders in driving down carbon emissions. And with the focus today across the country on ensuring reliability, and you also have rapid demand growth from AI, from the data center processing side of the equation, how do you see AI helping to ensure reliability, continued emissions reductions, and the ability to meet that growing load? Because sometimes those are competing priorities.
Right. Yes. Where I think we as an industry can continue to use AI is in trying to understand, okay, here we have the grid, and the grid is a given, right? And if you think about the grid in 10 years will look not materially different than the grid we have today. Unfortunately, we're not going to double it over the next 10 years. So we look at the grid as a fairly constant resource. And now we need to think about there's going to be retirements of fossil fuel generation, and then there is a ramp up of new generators, but they're mostly intermittent. And then we have storage coming in. So where in the grid can a hybridized system provide the highest value? We have found, again, the simplest one, 100 megawatt with a 4-hour battery. I think we all understand that. But what else can you do? What if you were to combine multiple storage? What if you go into part of the grid where you can hybridize it with another asset? This is especially true in vertically integrated market, not so much in RTOs, where you can materially increase the capacity factor. We have been able to show capacity factors of 70, 80% in we're designing one power plant right now where we can get to, I mean, we could get to 100%, but it's just economically prohibitive. But we can get to 97, 96% where we believe at market clearing prices. And with 97%, we're using 97% renewables and then filling in bits and pieces. And you can only do this because you can simulate with software millions of permutations and then find the sweet spot, right? And do this over many weeks. The new mode is then to compare, to share this data with an analysis with the utility, because as an IPP, we have only so much visibility into the power grid, and the utility has the complete view. But the utility often has limited view of how these new capabilities, the technology, how they're most effectively connected. So you basically starting to compare these nodes, and that's where you get better results than if you just look at it in isolation.
And one thing that you had mentioned early on, Jeff, that I thought was really important was having an organizational culture that is embracing AI. So as you think about being an industry that has a essential role for economic security, energy security, reliability, inherently you have a lot of risk averse leaders. So how do you get buy-in from these leaders that would then trickle down to their teams to create an acceptance and kind of an enthusiasm for AI in the workplace?
Yeah, it's a great sort of organizational culture challenge, and I do think it's something that that needs to have that tone at the executive level set. That I know folks are using it. You've got sort of little use applications, but I heard and actually saw a demonstration. Ethan Miansky, who wrote Co-Intelligence, presented to a group of CEOs, and he said, "Listen, you should be spending at least 10 hours a month personally on a frontier large language model just to understand the capabilities." And so that's something that I've been doing. It really is just remarkable what potential is there and like how it can really make your life easier. But if you don't have that sort of embracing of the opportunity, it's going to be much harder for the teams. We will see a lot from vendors, I think. And so, for example, we do in fire mitigation, we see AI being deployed through the folks at Technosilva who do some of that modeling work for us. And so I think you'll get sort of a push that's there, but you also want to create the pull by having that organizational culture where somebody's like, I think there's a role that I can use AI in, and I'm either going to go call a friend up and call Martin up and say, hey, help me think through how can APS and Bright Night figure out something around this technology, or how do I push the development of something that is going to be a little bit out of the box? I do think the core for utilities right now is making sure that you're focused on the data quality and that you've got good the fundamental platform is there so that you're not scrambling once you get a cool AI set and you realize that your GIS data is not accurate or you've got a lot of data quality issues. So you can do a lot of foundational stuff as the technology evolves, but I think it's going to take that personal investment of leaders in utilities to understand the power and the potential that this technology has before it's going to start getting driven more thoroughly through the utility. But I think it's absolutely going to happen. That's the path we're on.
And maybe one quick follow-up, just knowing how heavily regulated and closely regulated our industry are at the state level and the federal level, are regulators also kind of enhancing their chops on these issues? And how essential is it that they're coming along with you as you're learning and refining the different use cases?
Yeah, I think it will be important for regulators just understand the technology. I think in most cases, what you're going to see from like a just regulatory approval perspective, I hope, is that these will be efficiency drivers, and so they should be sort of inherently cost beneficial. I don't think utilities are going to do things that are not cost beneficial within this. So I don't know that it's something that you would need to get express regulatory approval to do. I think keeping the regulators up to speed on what the technology is doing and how it's being used and why it's being helpful is probably important. But I would not, you don't want to have regulations slow down the technology if it's able to come in and create value right out of the gate.
And this episode is going to be one of our first of 2025. So as we look into this new year, what might be some predictions on what to expect from AI? Do you see anything that's going to rapidly change or develop, or any words of wisdom for companies and what they can be doing today to be better positioned to start kind of more effectively harnessing potential? And maybe Martin, we'll start with you.
If you think about it, and I come back to the planning nature of our industry, where you have a power grid with a central clock. We're currently working on projects that interconnect in 27, right? And we're bidding with utilities in 28 and 29. And 27 is now, basically, in terms of where we're working. You look into the tech sector and you look at predictions. Kurzweil, for instance, he said 2029 we reached the point where AI is as smart as a human being in every aspect, and then from there on another 5 years or so, and then we're at super intelligence, etc. And by now he's not even the most aggressive in the forecast, right? Elon is certainly more aggressive, but a lot of others in the industry. So that's kind of what I'm trying to reconcile. Kind of, how does the next 5 years look like? What Jeff just described using AI in application, I think we'll see that mushrooming. We'll see, and I'm really impatient to see who comes up with solutions where, for instance, all the public documents in our industry are somewhere on an LLM, right? Because one of the key topics in our industry is there's so much regulation on federal, state, and county level. Just knowing these regulations takes decades of experience. So if you had an LLM or a number of LLMs where you just type in your questions and you get answers, I mean, that will speed up the process, because the situational awareness, where are we and where do we need to go to be in line with the regulations, will just help our industry to move forward. That's a simple example. That's an obvious one. That there are many others that will help us to improve. So I'm really excited about where the future is going, and I think one cannot overestimate the impact of AI.
What about you, Jeff?
Yeah, I think 2025 is going to be a pretty exciting year. I think it's just a building block in the way to, as Martin said, the potential that's going to continue to grow. I would say I'd again challenge my colleagues and those of us in the utility industry to just personally play around with the technology, get as much personal understanding as you can of just what the potential is. That will help you understand where it could be unleashed in the utility. And I think the area that to me has got a real potential early is in thinking of how these benefit customer experience. So if you think about using a large language model or AI to decide, like, why am I not getting penetration in some of my customer side programs? How do I optimize the delivery to the point that you get into this customer of one philosophy where you can have tailored information that is really responsive to that individual customer? How do I make the programs that we already have, like a smart thermostat program, more effective and better for customers? Things like doing pre-cooling in a better optimized way, so that when a customer's thermostat is turned up through the program, the house has already been pre-cooled in an optimal way. And if you could actually tailor that to an individual home based on history, you could have a much better customer experience. You may even be able to see things like, is an air conditioner failing? If you can look at historical use, whether to normalize it, and see, we can actually detect things that could benefit a customer. So those to me are sort of near-term things that we should be able to continue to deploy and to develop in 2025, and then just preparing for that long game, because I think the real power of this will be in being able to optimize across hopefully we have some more transmission, but we can optimize across the system the efficient dispatch of the resources that we're putting on, and get the most the most asset utilization that we can from the grid to help address the load that's coming on, and keep bill pressure low.
Well, thank you both for investing so much time in these issues and really the work that you're doing together to drive innovation here. I know, like you said, Jeff, as an industry, we learn a lot from each other. So thank you for all the hours you're spending a month and learning and sharing with your peers.
Absolutely, Brian. This was fun. Thanks.
Yes, thank you very much, Brian. Really appreciate it.
And that's our show for today. Thank you for listening, and come back next week to hear more from experts and industry leaders who are talking about the innovative ways electric companies are building a cleaner, smarter, stronger energy future for the customers and communities they serve. You can subscribe to our podcast on Spotify, iTunes, Podbean, or wherever you get your podcasts. Just search Electric Perspectives. I'm your host, Brian Reel. Thanks for listening.